Yeah, I'm sorry, it is suddenly stopped. Okay, and then instead of using oxygen, the mediator could be used. Okay, a mediator. All right, a mediator is the kind of a molecule that transport electrons. By what shuttling. mm, Okay, here. Yeah. The system is like that. This is electrode strip. Okay, and then it gives you three electrodes. Okay, one is this is the middle part is reference electrode, silver chloride. Yeah, as you see, silver chloride. This part can be made very small, and here is the carbon working electrode. Okay, with coated with glucose oxidase, and this one is another carbon working electrode coated with mediator, but no enzyme here. And then blood. Uh, this is for blood. Yeah, blood is applied here, and then blood now is a liquid. Now it is sucked to this working electrode. Okay, and then what's the principle of this mediator type glucose sensor? Look at that. Yeah? This ferrocene is one of the mediators. Okay, and then this mediator now the this glucose, yeah, is oxidized by glucose oxidase, and then it is oxidized to gluconolactone, and then in this process electrons are produced. Okay, here, as you see, here, look at that. This glucose is oxidized to gluconolactone, and then two electrons are produced, and then that electrons are carried uh, by this ferrocenium ion. Okay, this is a 1 prime dimethyl ferrocenium cation. Okay, and then now electrons are going to this ferrocenium ion, and then it is reduced. This in this ferrocenium ion, the ion oxidation state is +3. Okay, and then by receiving two electrons because this one glucose molecule is corresponding to two ferrocenium ion, and then this ferrocenium, the ferric ion is reduced to ferrous ion. Okay, and then here this is ferrous and the ferrocenium and the ferrocene, it is undergoes very rapid and reversible electron transfer, and then by applying the working electrode potential at negative at oxidation at the positive enough to oxidize this ferrocene to ferrocenium ion back. Okay, understand? And then uh, by applying about zero point 0.2 volt, okay, 0.2 volt, then you can oxidize this ferrocene to ferrocenium ion, and then this ferrocenium ion uh, ions are ready to accept electrons from glucose. Okay, in this case, in this scheme, oxygen, oxygen is not needed. Okay, so without oxygen, and then glucose concentration can be measured by measuring the current of this ferrocene oxidation current. Okay, here if you depend on the oxygen concentration in blood, yeah, but in this case uh, you don't need to or adding the ferrocenium ion, since this ferrocenium ion accepting electrons to become ferrocene, and then ferrocene is oxidized again to ferrocenium ion. So this is there's a cycle. Okay. So the ferrocene, okay, and then back to ferrocenium. Okay, this cycle is made. Okay, so this ferrocenium ion is called a mediator. Okay, so with is very small amount of ferrocenium ion. Yeah, so no problem to measure the concentration of glucose. Okay, so here the current at the working electric potential maybe at zero point 0.2 volt is proportional to ferrocene concentration here, and ferrocene concentration proportional to the glucose concentration in blood. Okay, yeah, this is second generation of glucose sensor. one problem here in blood. Ascorbic acid, uric acid, aminopen can be oxidized at the same potential required to uh, oxidize the mediator. Yeah, this is the one problem. Okay, in blood there are the large amount of ascorbic acid, uric acid, and acetaminophen. Okay, so to correct for this interference, need the second electrode coated with the mediator, but without enzyme. Here, look at that. This one, this part of working electrode is coated with glucose oxidase and mediator, but this one is coated with only a mediator, no without any enzyme. So response of this one, you take two responses and then through glucose oxidation, current is the current from this electrode minus current from this electrode. Okay, yeah, okay, because the interference are also oxidized electrode 1, working electrode 1. The current due to glucose oxidation only is the current difference. Okay, difference measured at this one. Working electrode 1 and working electrode 2. Okay, yeah, this is a second generation of glucose concentration measurement. Okay, here is the completely the different. The sense has been made, and this is on the market, which is based on electrical wiring of enzymes and mediators. Okay, here is the glucose. Okay, then this part, this is a kind of cofactor. This complex molecule is called pyrroloquinolinquinone (PQQ). Yeah? This one in the presence of glucose dehydrogenase. Okay, the electrons from here, okay, from glucose, it is oxidized by glucose dehydrogenase, and the electrons goes to this one. Okay, pyrroloquinolinquinone, and it is reduced to quinol. Okay, this hydroquinone. Okay, from quinone. And then you measure the current due to this oxidation of pyrroloquinolinquinone. Yeah, this is electrical wiring. But how can it be done? Okay, here this is a PQQ molecules, and this is PQQ now accepting electrons to become PQQH2. This is hydroquinone. And then this quinone is oxidized by what? I'm sorry. This is glucose dehydrogenase, and then this reduction what the electrons now goes to this osmium complex. Okay, here is a very long polymer backbone. Okay, and then it has this one osmium complex. Okay, osmium containing the complex on this backbone. Okay, and uh, now this part, yeah, this is all this system is hang is hung on this large polymer backbone. Okay, so idea is that there is a long polymer chain. Okay, since this the polymer chain is so long, and then it can have access to the active site of an enzyme of glucose, in this case dehydrogenase. Okay, and then this glucose dehydrogenase. Okay, I think this one now oxidizes glucose to gluconolactone, and as you know the enzyme molecule is very big. Okay, very big, and then the active site is buried, usually buried inside the enzyme. So in the electron transfer from the enzyme to the electrode is not easy, so there must be a way to have an access to the active site. So this long chain, this one now connects to the connected to this electrode, in this case carbon electrode, and then now this one can have an access to the active site of glucose dehydrogenase, this enzyme. Okay, you understand, right? This is called uh, electrical wiring. Okay, electrical wiring. The to get the electricity, and then you need a wire. Okay, and then you connect your the plug to the outlet of the electricity. Yeah, usually in the on the wall like that. this molecule is a kind of wire connecting the enzyme and this electrode, okay? And then these electrons are moving. First, the electrons goes to this PQQ, uh, pyrroloquinoline, and then it becomes pyrroloquinoline and hydroquinone, okay? And then this one is oxidized, and then electrons now goes to this osmium complex. This osmium is the oxidation state is plus 3 or plus 2. And then when it is plus 3 state, and it accepts one electron to become plus 2, and then electrons are now through this backbone of polymer, and then eventually this electrons now goes to the carbon electrode, okay? Although the this mechanism is looks quite complicated, actually this scheme works quite well, really really well. Yeah? So using this method, very good. Glucose sensor has been developed. It has been developed by a professor at Texas A&M University, engineering department. Okay? Then he made. He started a venture, and then he sold the venture to a big company, and then he became really really rich. Someone said he's not a millionaire but a billionaire. Okay, let's stop temporarily here.